Okay. Well, everybody, on behalf of WMA, I want to thank you for joining us today. One positive thing about Zoom tours is we will be able this time to do 5 different facilities out at NIAR. If it was an in-person tour, obviously we would probably be only to hit 1. So first of all, I want to thank Tracy Fries. She's the Director of Communications out at NIAR for setting this up for us and getting this all ready so that we can actually have an opportunity to see more facilities than we typically would. Since the inception, NIAR started in 1985 at Wichita State University and has made a name for itself as the most compatible university-based aviation research center in the United States. So we are very fortunate to have this in Wichita. We're going to start each location. We do have a director available. I will introduce that director and we will show the video, and then they will take questions and answers from anybody that has them. If you could just put them in the chat and we can go from there. So first off, we're going to introduce Luis Gomez. He's the manager of virtual engineering at AVET. Luis.
Hello, everyone. This is Luis. How are you doing?
Good. Thank you for being here.
No problem. So my name is Luis Gomez. I'm the manager of the virtual engineering and testing laboratories that you're going to have the opportunity to see the video for. And in it, you will see the current capabilities that we have and how do we take the virtual analysis to the next level. Thank you to the specifics and targeted coupon and component level testing that we can do in our lab that is done to support all this analysis work that we do. So I'll be happy to take any questions that you might have.
The AVET lab really brings NIAR to the future. And what the AVET lab does is everything that we do in our real world lets us do in a virtual world.
Right now, we're probably one of the only place in aerospace where you have on that single building the capability to conduct virtual as well as physical testing in the same space.
It allows us to save cost, save time, and really advance new research to the market faster.
The labs are initially focused on structural dynamics and crashworthiness.
We are experts in 2 fields, testing and numerical analysis. Now, the foundation for successful full-scale numerical analysis lies in accurate definition of the material models. And at AVET, we have a dedicated team specifically for the materials research and development, and that's what we do here.
So you can see the level of details that we have in the ATDs and in the seat to predict failures and help them in the certification process.
We're also looking at what kind of injury patterns may be typical for aircraft crashes that currently we may not fully understand.
So the virtual flight testing lab is a virtual environment where we can simulate all the different aircraft systems and how they behave in the real world. We have mathematical models that are able to capture the aerodynamics behavior, and we can estimate all the forces and the influence that they have on the structure and the flying physics of the airplane. And then we have coupled this physics-based library with a flight simulator tool in order to be able to interact real time and to be able to have a virtual flight by a pilot on the simulator and evaluate how that new system or how that new aircraft is going to behave during flight, without the need of having to build a full-scale prototype of the vehicle. So a few years ago, we were approached by the FAA. They were trying to integrate small drones into the US airspace. And one of the questions that they had is, how severe it is an impact between a drone and an aircraft.
These are an example of some of the UAVs or drones that we tested with. We both did physical testing and transitioned into simulation work.
For example, we can look at what happens if we shoot the drone and we are trying to impact an aircraft, a windshield. So we like to look at the complete drone on a real test, and then we try to validate the simulation. As we can see, they behave similarly. That comes with a lot of more work. We look at loads, we look at strains.
So that's the real value that we bring in this lab, is just to be able to avoid all that full-scale testing, to have good predictable models that we can have confidence, because we do a lot of testing in the building block testing lab at the coupon component level. And then that way we can provide to our clients data in a short period of time without the need of having to wait multiple months or years in order to be able to have the proper funding or the proper test articles to be able to run these very large test programs. So the objective of the building block testing lab is for us to be able to have testing capabilities that we can use to characterize materials and components that we use for our simulations.
So this is the building block approach, and it gets the name from the building block approach methodology that a lot of the engineering fields use today, particularly the aerospace industry. So how that works is that you have your problem and you divide it into a pyramid, where basically you have usually 5 levels. You have the coupons, elements, details, subcomponent, and the component, which is whatever you are trying to study, certify, design, manufacture. So usually you start at the bottom with the coupon level testing, and you move up with the complexity, and you're putting all the effort on that basic level to try to understand exactly what is happening.
And then by conducting these coupon and component level tests, we can avoid having to run full-scale tests in order to have good predictable models.
So one of the reasons that we built this lab, one was to support that those numerical model analysis, and another one is to have a place where we can do very short turnaround, quick projects for the FAA or for industry, and also one of a kind, things that you don't do every day that require an engineer to think about how you're going to do the test.
55?
This is the preparation or conditioning room, basically, where we are preparing the specimens for the disinfectant effect project that we're doing for the FAA in relation with the COVID. They want to understand the effect that disinfectants have on the strength and flammability of cabin materials. So basically the materials that you have on your seats or that you have on the inside of the airplane, what happens after you wipe them 1,000 times with a chloro solution or something like that. Obviously, we're not using chloro, we're using the product that the aerospace industry is using to clean the aircraft, but they want to understand, is it going to affect the strength of my material? Is it going to change the flammability characteristics of my material?
This is the Crash Dynamics Laboratory, where we primarily do testing for aerospace seats.
We use this in aerospace testing almost daily.
We can test anything from aerospace seats to automotive testing to child car seats.
There are load cells inside of his ribs for side impact testing.
It's a lot bigger capacity than our older system, so we can go up to a lot higher accelerations, up to 90 Gs. It also gives us a lot more control over the acceleration and matching different profiles for those tests.
So we have an in-house dummy calibration lab.
So every one of our tests here in the lab deals with a crash dummy. We have to have calibrated, certified crash dummies for any test that we conduct. You could have an entire dummy getting tested in one test, like a hit to the thorax on a fully assembled crash dummy, or you could have something as small as just the head getting tested individually.
After we're finished with the dynamic tests, we have a specialized software that we use to analyze and report the data back to the clients. It works in conjunction with a pre-test checklist that we fill out that we can then feed into our program. So we're able to provide a final test report back to the client in about 5 to 10 minutes after the dynamic test is ran.
I think one of the unique things that Wichita State brings is its integration of students and our focus towards applied learning.
And the beauty about this group and why I really like them is because they cannot just run the physical testing, the experimental side, but also the computational side.
And what this does is allows the students to get firsthand knowledge of things they don't learn in a textbook, and makes them very adaptable to the workforce once they walk across the stage and graduate.
And that is something that I really consider to be unique. Most of us either specialize on one side or the other, and I think these guys help everybody bring everything together that we do on this Advanced Virtual Engineering and Testing Laboratory.
One of the key things that I think Senator Moran has done in his tenure as being a senator on defense appropriations is really be the connector between the Department of Defense and higher level people like the Secretary of the Army, the Secretary of the Air Force, and from the commercial side, the NASA administrator, bringing them to Kansas, showing them what we have to offer, and really then he steps back and lets Kansas sell itself. And so I think that's one of the most unique attributes of Senator Moran is Kansas sells itself. He's just the dot connector, and then from that point on of how Kansas can and Wichita State and NIAR can really benefit the United States and Department of Defense and other federal agencies.
Did you want to follow up with anything on that, Luis?
No, not really. I'm open to anybody to answer any questions.
Does anybody have any questions? That is amazing. When did that facility, when did you start that facility?
We opened the facility in November of 2019. Even though that's when it was open, we have still not had an opportunity to do the grand opening because of all this COVID situation, but we have been working on it since November 2019. Yeah, it's just, I don't think we say on the video, but it has about 15,000 square feet of laboratory space. And we have about 60 people working on that laboratory between full-times and students any day.
I was curious how many students you had working there.
Yeah, about half of them are the students, mostly graduate students. We have a couple of undergraduate, but most of the students that we have in our lab are either master's or PhD students from mostly aerospace and mechanical engineering.
That is amazing. Does anybody have any other questions for Luis before we begin to the next department?
I think somebody has a question about potential testing. So basically, we at NIAR, we work with any client. You can either go to the website directly and look on how to do business with us, or you can look for the specifics of every laboratory. You will have a website where you can see all our contact information and phone numbers. And to be honest, it's very, very simple. We are very used to deal with a lot of different companies and government agencies. So it's something that it doesn't really take too long to get done.
Do you reach out to them to find you? That's a good question. Do you reach out to companies and ask them if they're needing any testing, or do you typically get your clientele by them going directly to you?
It really depends. Sometimes the mouth-to-mouth works, and some people come directly to us because of our expertise and what we have done in the past. But sometimes also we see opportunities in conferences or working with other clients, or maybe even through the social media, where we see somebody that is working on something that we directly specialize, and we reach out to them and tell them that we can do the work and go from there.
Okay. Well, we're going to keep Luis around, and at the end, if we have any wrap-up questions or you think of any as we continue to go through all of the facilities, please put them in the chat and we'll go back.
Okay, sounds good.
Perfect. Thank you. The next facility we're going to do is 3D Experiment Center. We have Brian Brown here, Director of Robotics and Automation. Hi, Brian. How are you today? Hopefully we have Brian on.
This is Brian. I'm
Hi,
doing
Brian,
good.
how are you?
I'm doing great.
Good.
So Yes, I'm part of the 3D Experience Center, and basically it's a combination of a couple different labs. I believe Tracy will show our video on it here in a second, but it's a combination of a couple different labs where it's a virtual reality center, my robotics and automation lab, and then our 3D printing and reverse engineering and scanning area. So it's kind of a combination of both 3D and real things all in one. So it's quite the area. Tracy, do you want to go and show our video?
The goal of the 3D Experience Center is to take something that usually takes 3 years to build or 3 years to design and shrink it down to 90 days. And that's really what makes Wichita State and the 3D Experience Center different. One of the first areas that we walk into is called a collaboration room. What we have here is a power wall. Any of these monitors can be shipped to an individual computer station. It's called a collaboration room because it's set up for 8 people. 8 people that have all the right tools that work in an efficient group to do one task. And that is to take something that used to take 3 years down to 90 days. One of the key components here with the 3D Experience Center is being able to visualize it in a real-world scenario. So if you follow me in is one of the special places that we have, our Virtual Reality Center. And here's really the heart of the Virtual Reality Center. It is a power wall. What's really special about this is the size of the power wall. So you can kind of get a feeling of how large it is here. Most people say that I've seen 3D, I've seen a 3D TV, I've seen a movie in 3D. This allows you to explore it on a one-to-one scale. If you're watching it on TV and you see 3D, you're seeing a miniaturized version. On this power wall, we can bring a part forward and view it into a one-to-one scale. So if you see when we're able to explore a model, then you can actually go into the model and look at every fine detail. And then the thought process here is you have a collaboration group that works together. So you could have a systems engineering combined with the structures, combined with a hydraulics engineer, and basically really integrate a model in a virtual world. Now I need to be able to make something that in a way that typically isn't done by hand. So now we'll enter into the robotics and automation lab here at Wichita State. So as you know, this lab, quite different. One of the special things we have here at Wichita State that no university has is what we call the MRAM. It's a multi-robotic advanced manufacturing system for MRAM. You'll like the names of these because they work in pairs. So we have Razzle Dazzle, Tick Tock, and Ping Pong. What we do here is we have 6 robots that do many different tasks, and basically they work together to perform the task. One of the things that the Innovation Campus does is allows students to get in here and work with robots. You go from a Lego Mindstorm that people are doing in middle school and in elementary school, and you follow that path through where now they get to play around with the MRAM here at Wichita State. It is truly one of the invaluable learning experiences, and that's what makes us different here at Wichita State is the applied learning. Having a student be able to work with one of these robots and build something that then when they graduate, they can take it to the industry and perform. The next room we'll go into, the laboratory, is called the reverse engineering. Joel here, he's one of the directors of the lab. He's going to kind of demonstrate what reverse engineering does. Just showing you how easy it is to do. I'm going to have Joel just scan my hand. So I'm going to try to keep it still and show you how quickly it can be done. Just that quickly. I'm quite older than I think. Anytime I scan my hand, I show more wrinkles than I think I have. But it shows the detail. If I turn my hand over, you would actually see my fingerprints as well. So that's how accurate the scan is. So again, it's really that fast, taking a physical part and turn it into a digital part. then if I wanted to print myself a ring or print a model of my hand, basically now I have the digital image captured. So WSU is quite unique as far as any university that I know of the amount of scanning equipment that we have. Now, what happens if you want to print? So that's the next lab, is our additive manufacturing lab here at Wichita State, is a whole collection of 3D printers. Various printers that do different things if you go over here from the tabletop size over to the larger printers, and then each printer has a specific unique thing that it can do. This is one of my favorite printers because this one just uses plain copy paper. Every sheet of paper it takes off, it glues and stacks it to the next paper, and then it uses ink just like your inkjet printer and builds up a model, and then you just break it off. But basically you can see this is the type of resolution that we get out of the model. It comes out in full color, and then you just break the paper off, and so this is basically stacked copy paper. So this is one of the last parts of the 3D Experience Center, and this is basically our showroom. Now this cast is quite unique because this was one of my female students that actually broke her arm. She could take a shower with it, she could swim with it, and she could itch it if she needed to. So quite unique. I told her that yes, I'll let you do it, but I get to keep it in the display case when it's over with. So I hope you enjoyed my tour. Feel free to come and stop by. I love to have fellow shockers here, and I love to show this off. So I'll see you next time.
So yes, with the 3D Experience Center, it is a very exciting area because we can go everything from design all the way through a prototype in the end, and even consider the manufacturing as it goes with the robotics lab. More specifically, I am on the robotics side of it, where we'll do a lot of robotics integration projects and robotics projects in general. But a lot of times we end up using the other labs to support that and to support the rest of NIAR in the way of the inspection, the reverse engineering, or printing prototypes, printing tooling, printing different parts. And then of course, using things like the virtual reality lab to actually visualize that and see it and be able to see everything come together before we ever start building anything. So with that, I'm open to questions. Otherwise, I could talk all day long about this stuff.
What questions do people have for Brian?
All right, you have an active group.
We do have an active
Brian,
group.
this is Lee Gallerano. Can you hear me?
Yes, sir.
First of all, that was absolutely fascinating, especially the cast. That's an incredible example. What kind? Do you guys have any kind of typical type of use case for the 3D printing, and then how do you take the what was the virtual? I can't remember exactly what it was called, but the virtual piece, and then translate that into the 3D printing itself. Does that make sense?
Sure. No. So oftentimes, if I'm going to reverse engineer something, let's say I want to reverse engineer my headphones or even my cell phone or something of that nature, the 3D scan model will allow us to come in and scan the object, whatever it might be. Dr. Tomlin did his hand. Hands and ergonomic or organic things are generally somewhat unique to us, but generally when we have non-static things or static things such as cell phones or headphones or something like that, we can come in and scan it and do that scan of it. And what that does is that creates essentially a point cloud model for us. From that, we would then start to stretch surfaces across it to turn it into an actual model and an actual 3D model. We've done many cases where we've had people bring in old parts or car parts or things that they can no longer get manufactured or no longer find, and we'll actually scan them, reverse engineer them, and turn them back into a CAD model for them. Once we have the CAD model, then we can actually take that and either send it to the machine shop to get it manufactured out of metal, or we can go the 3D printing route. Again, generally we'll start with the 3D print route just because we want to get that fast prototype out of there so we can get a prototype within a day. And then once we determine that, yes, this part is good, or maybe we make some modifications to it, we test that and we make sure it's good, then we're ready to actually go to the full-on metal route and go that direction. A lot of times for my lab where we do the robotics is when we have people that are interested in inspecting many parts at once, or inspecting a whole line or a series of parts, we'll actually automate a lot of those inspection routines to where you can basically have the robot tend to cell phones as they come down the line, or tend to a whole bunch of parts, and then automatically scan and inspect them as we go. Now, one thing I like to mention a lot of as you listen to these different NIAR labs is we could take something, scan it, reverse engineer it, 3D print a prototype of it, but if the part wasn't accurate enough, or if the part was having problems for stiffness or construction, that's when we engage like Luis's group and we say, hey, Luis, I've got this part, it's been failing on us. We've got the 3D model of the original part. Help me design a better part that fits within this envelope that can handle the stresses or handle the different features that we need. And so a lot of times we work those all in conjunction with each other. And again, this is all under one roof where we can take the scan to the 3D print, to the virtual model, to the production end of it with robotics, to the virtual reality lab where we can actually do the virtual inspection of it. And basically, again, you're tying all these together. So as you guys are listening to the different NIAR labs, you can kind of see how they all relate together into this giant manufacturing ecosystem of all these different unique little areas of analysis to prototyping to inspection to, you know, all the different things that you're going to get to see and hear.
That's fantastic. Thank you so much.
I got a quick question. This is Scott Schaefer. How, what's the process of getting like a quote or an estimate on getting something scanned? And because we do that a lot where we do some reverse engineering and have to develop some things. But what's the process that we'd have to do to get that in process?
So Tracy put in the website, working with us and doing business with us. Really what you end up doing is just contacting one of the different groups. I mean, for example, if you contacted Luis and said, hey, I'm interested in doing scanning, he would turn you back over to us. We're all one big group and we all know each other's talents in each other's areas. So typically what will happen is we'll just get you to the right director or the right lab manager. And then from that, we all kind of do our own quotes and we build up a quote for you to say, oh, you're wanting to scan the entire side of a building. Well, that's going to be one price versus if I've got just a single individual part, that's going to take a lot less time and things like that. We are a nonprofit. So basically what it is the university sets our rates and then that's what we go based on. So everything is based on that. And then we go from there. Tracy actually added in the chat window for additive manufacturing and reverse engineering specifically would be Mr. Chris Rempe. He's right next door to me. And he's the one that anybody that you talk to would end up turning you over to him. Whereas again, if you was asking me about doing a lot of stress analysis, I would turn you over to Luis or one of the other groups as well.
Okay, thanks. And since I'm talking a little bit here, what about I saw something on there, additive manufacturing. Do you do metals as well? Or is it only plastic 3D printing?
We do have metal additive manufacturing. Right now, the metal machines are being used primarily for testing and evaluation. So basically, we're helping do a lot of quantification and determining, are the metals going to be good enough for aircraft? Are the metals going to be good enough for interior parts, or can they be used for different things like that? We do have the ability to print both Inconel. We can do Inconel, we can do stainless, we can do titanium. Basically, we've got a whole different array of materials that we can print on, but we can do a number of different options. There's also, like Sean's mentioning in there, the ability to do powder bed metals and then direct deposit metals, cold spray materials, that type of thing as well. So really, it kind of covers a wide array of things. Really what it is when we start looking at prototyping for somebody, we'll try to help you make sure we go the right route. That if it isn't a situation where you would use additive manufacturing for it, you would use a different technique or a different process, we would try to help push you and guide you in the right direction.
Okay, thank you.
Definitely.
What kind of backlog do you guys have right now?
It really varies lab to lab. That would probably be more of a Tracy question where she has kind of overview of the entire areas. Most labs have capacity for a lot of additional projects or a lot of additional things going on. For example, Louise talked about the lab staff versus students. My lab actually has about 10 staff members and 50 students that work for us. So we try to help, have a lot of capacity to where we can do a number of different projects for different companies. One of the other big things that we'll do a lot of times is actually set up NDAs with those companies. So that way anything proprietary or anything unique to you stays with you and you don't have to worry about it getting shared or getting sent off. Because we do work with a lot of proprietary and we call it secret, but it's not truly a government type secret, but we call them secrets so the students understand that these are something very unique to that company and are not to be shared with anybody else.
Thank you.
Very good. Yeah.
Does anybody else have any questions for Brian before we head to the next facility?
Excellent.
Looks like we're good. Brian, thank you so much.
Thank you.
Okay, we're going to move on. Facility number 3. It looks like we're going to the ASTEC facility. We have with us Melinda Laubach-Hawk, Director of Sustainment. Good afternoon, Melinda. I think she'll come on here in just a second. Melinda, are you there?
Okay, I think I got it unmuted. Sorry about that.
That's great.
Good afternoon. I'm Melinda Laubach-Hawk, the Director of Sustainment out at the Aircraft Structural Test and Evaluation Center. For those of you that are familiar with the city of Wichita, we occupy the old Kansas Coliseum. In that facility, we do sustainment work. You'll see in the video some discussion about digital engineering and digital twin. That is done at our facility. We also are the 3rd largest test facility in the world for full-scale testing behind Boeing and Airbus. And we do some composites work and also some ballistic work out of here at the facility. Most of our projects are military-based, so unfortunately I'm not allowed to share my camera for these type of events. But hopefully you'll enjoy the video, and if you have any questions afterwards, I'd be happy to answer them. Thank you.
Hello, I'm Dr. Melinda Laubach-Hawk. I'm the Director of Sustainment for the National Institute for Aviation, and this is the Aircraft Structural Test and Evaluation Center. We're located a few miles north of the city of Wichita. About 10 years ago, if you would have come to this facility, you'd be seeing sporting events and rock concerts. However, we began operating out of this facility in 2012, and we converted it to a state-of-the-art research facility with over 500,000 square feet of testing and sustainment capability. Some programs that have been completed here since 2012 are the Learjet 85 structural test, the structural test to support the MQ-9 Reapers, structural teardown of KC-135, and 3 Joint Strike Fighters. Later today, you'll see some of the work we're doing now, which includes the digital engineering of the UH-60L Blackhawk and the B-1 bomber.
We're here at NIAR's full-scale structural test lab, where we evaluate the structural integrity of airframes. We're standing here in front of our PASCOM fixture, where we can test pressure and axial loading on aircraft panels. We moved to this facility in 2013, increasing our test floor space to 120,000 square feet. We have a combined hundreds of years of experience, including engineers, tech writers, instrumentation team, inspectors, technicians, and student employees. We'll test anything from small components to full aircraft, mostly in aerospace, but occasionally outside of the industry. We perform static testing to design limit loads, ultimate loads, or even to failure. Durability testing to generate fatigue life data, and damage tolerance testing where we induce artificial damage, for example, impact damage in composites, or initiating cracks in metallic structure, and monitoring damage growth or change in performance with various data and non-destructive inspection methods throughout testing. Instrumentation data we may collect during test include strain, displacement, loads, temperature, pressure, digital image correlation, along with audio, video, and high-speed video. The most common inspection technologies we use here are ultrasonic, dye penetrant, eddy current, and magnetic particle. We also have laser shiography, pulse thermography, and X-ray technologies here at NIAR. We have full machining capabilities with CNC machine, mills, lathe, as well as cranes and forklifts for heavy lifting. Here at the Full-Scale Structural Test Lab, we enjoy the advantage of having everything under one roof. Engineering services and test plan development, test fixture design, machining, and complex fabrication, test setup and operation, data collection, non-destructive inspection, and finally post-test structural teardown and evaluation.
I'm Caleb Sadoff, Senior Research Engineer and Laboratory Manager for the Experimental Mechanics Lab here as part of ATLAS, which is the Advanced Technology Lab for Aerospace Systems. We work very closely with the other laboratories here at NIAR, primarily the Composites and Advanced Materials Laboratory. As part of the Composites and Advanced Materials Laboratory, we do perform mechanical testing, so this would be what most people would think of the qualification and equivalency programs that we run. These are to generate material properties, tension, compression, shear, bearing properties. We can do that at temperatures down around -65 degrees. We can go colder as well. It's all liquid nitrogen cooled, and we can also go up to temperatures to 600 degrees Fahrenheit with high temperature capabilities coming soon for the ceramic matrix composites or carbon-carbon composites. And in our element testing laboratory, these are the bigger load frames. We go from 110,000 pounds up to 550,000 pounds, axial torsion capabilities, and this is where we test components, bonded structures, or representative elements before we come to the full-scale testing.
One of the programs we're really excited to partner with the Army and Sikorsky Aviation on is the reverse engineering and digital twin of the UH-60 Blackhawk. One of the problems that plagues the Blackhawk fleet is it was manufactured many years ago in the two-dimensional age, the non-digital age. What we are doing is we are bringing this aircraft into the 3D digital age. So we are taking one of these helicopters completely apart, scanning it with high fidelity scanners, reverse engineering it, and creating manufacturing quality models that we can make parts from if we need to address parts obsolescence issues within the fleet. Another thing we're doing, this particular helicopter will be structurally tested in order to validate engineering models we're creating, which will give the Army the ability to perform organic engineering capability of their own. Another recent digital engineering program we have started with the United States Air Force is to support the B-1 bomber. This aircraft was moved from Tucson, Arizona a few months ago. It moved 5 states in 9 days. It's half a football field long and 3 lanes of traffic wide. And we're doing the same thing we did with Blackhawk. We're taking it apart piece by piece, scanning it, reverse engineering it, and then digitally reassembling it to move it into the digital age. In addition to the fuselage, NIAR is performing reverse engineering and digital engineering efforts on all of the structural elements of the B-1 bomber, including the wings, the horizontal stabilizer, the vertical stabilizer, the engine nacelles, and the stinger. Once we remove the parts from the airframe, we have to clean them up in order to scan them. We remove all paint, primer, and sealant, and then use high fidelity red and blue laser scanners to capture all the detailed part geometry. We hope you enjoy the virtual tour of our facilities today. As you can see, our facilities and our capabilities place NIAR and Wichita State University in a unique position to support both commercial aviation and military aviation through emerging technologies and sustainment of aging airframes. So the next time you're in the air capital city, feel free to come by and visit one of our facilities. You can learn more about NIAR and Wichita State University at www.niar.wichita.edu.
Does anybody have any questions for Melinda? I guess I'll start. How long does it take, Melinda? You have the B-1 bomber there. How long is that project going to take for your facility?
The B-1 bomber is a 6-year program. The UH-60 helicopter is about 2 years.
So is the outcome of that program, is it basically going back to the drawing board for the manufacturer where they are remanufacturing a newer model that's more structurally sound?
No, the idea is from a sustainment perspective to be able to basically digitize the airframe. That way, if we need to go make parts, a lot of the machine shops in the area don't really like to work off of two-dimensional drawings anymore. So we're providing them the 3D CAD models so that they can machine replacement parts. In addition, we're developing some high-fidelity engineering models to help the government directly own data that will allow them to do engineering analysis at their facility as opposed to continual reach back to the OEM.
Thank you.
How many students and employees do you have at your facility, Melinda?
As far as the ASTEC facility, there's about 120 employees out here now. Probably about 50% of them are students. With regard to the digital engineering enterprise we've established at NIAR, there's about 350 personnel working those programs across multiple different locations.
Just quite the organization. Does anybody else have any questions for Melinda before we move on? Melinda, thank you very much.
Thank you, and I'll stick around to the end if there are any additional questions.
I appreciate it. Okay, let's continue to go. We're going to do right now, we're going to tour the Emerging Technologies facility. We have Jeswin Joseph, who's the Program and Research Manager. How are you today?
I'm doing pretty well. Glad to be on here.
Are you ready to do the video? And let's see. Let's go ahead and just start.
The Emerging Technologies and Advanced Manufacturing Labs, located at the National Center for Aviation Training, is a cross-functional, multidisciplinary lab that works and collaborates with other labs at NIAR. The big question is, how do we make the appropriate iterations for a manufacturing process based on a perfect, ideal part? We're developing machine learning algorithms so that we can use it in additive manufacturing, especially in process monitoring systems, where we have software that is going to read what's happening in the process, make the appropriate iterations so that we can get a perfect final part. One of the recent projects that we worked on, which is now a provisional patent that WSU has applied for, is a fully automated cobotic finishing system. Basically, the idea is you place a part in front of a robot, in this case a cobot, which is a collaborative robot, and this robot will scan in a matter of seconds and sand it for you if you want, or polish it for you if you want, or do the appropriate automated pathing operation for you.
Hello, my name is Xuanyi Li. I am the supervisor of Emerging Technologies Lab. One of the most exciting projects that I'm working on is on the CBAM. CBAM stands for Composite-Based Additive Manufacturing.
The CBAM is the only sheet lamination additive manufacturing machine in the world. The Big Area Additive Manufacturing Machine, or the BAM, is a 6 foot by 6 foot by 12 foot large-scale additive polymer machine that is used to make very large components, be it molds, tools, fixtures. One of our latest and most exciting machines that we've received is the VRC Gen 3 robotic 7-axis cold spray system that is used to repair worn out parts. It is especially used in sustainment activities. The LaserTech 65 3D by DMG Mori is one of the few machines that can do hybrid manufacturing, which means it can do 3D printing and milling in the same build envelope. The RPMI 222 is a metal directed energy deposition machine. It is one of the first metal AM machines we received, especially for directed energy deposition, and we worked on projects with the FAA and with local companies to develop material properties and processes. One of the most notable projects that NIAR owns the design for is the small UAS project that we worked on a couple of years ago along with Dassault Systems. We successfully were able to turn it around in actually 10 months, which is almost unheard of in the industry. One of the projects that we're working on as part of the NIAR UAV lab is to design from scratch an airship. You can call it a mothership that launches drones. As part of this project, the students, our applied learning students, have focused all of their efforts from clean sheet design. Basically, we started with whiteboards.
The students do testing work and also design work on CATIA platform.
Our goal was to come up with the best design with the highest endurance. And at this point, we are already doing simulations and doing endurance trials.
Would you like to address that any further?
Well, I just wanted to say it's a pleasure having all of you virtually with us. Hopefully some of you can join us in person. It's a lot more exciting in person. But yeah, we're like Luis and Brian and Dr. Melinda has mentioned, it's pretty easy to work with us and get a hold of us. And one of the things that the Emerging Technologies Lab focuses on especially is we work with a lot of small businesses to help with technology readiness level elevation. So we can start with a small concept and kind of walk you through, to make a product, to design a new prototype, etc. So it's not just the large structures that we focus on specifically, but we are very well versed with smaller components, smaller ideas, and we can walk you through the patent process with our Wichita State Tech Transfer and Commercialization Group also. So if you have any questions with regard to that, I would be glad to answer.
And I think there's been a few questions in the chat that Tracy's been answering, but just like the other divisions specifically, do businesses come directly to you or do you go out and seek business as well?
It's a combination. In fact, one of the things that I'm sure the other directors and managers have experienced this also. I've been with NIAR for about 15 years. So in my 15 years, I've had a lot of students, graduate students, student assistants. In fact, they're now managers in the different companies. And because they know the quality of work we present, they in fact bring us back more projects. And we kind of become their offsite R&D team or even our design team. So in fact, a lot of our former students are our greatest ads, actually.
That says something for you guys, doesn't it?
Yes, it does.
Does anybody else have questions before we move on?
I was curious about the mother, was it called the mother drone? Can you talk a little bit more about that and maybe some practical applications for that?
So we are exploring with a variety of industry partners, and this design, we've started it off here. You've probably seen videos or clips. Amazon is attempting drone deliveries. So we're working with certain groups on launching from this mothership, this large, massive blimp, can be launched drones. So we're working with College of Engineering professors on some of the wireless capabilities, signal transmissions. Our focus is validating the design from the clean sheet design upwards. We're also working on beginning to work on concepts with urban air mobility on how large blimps can transport people, for example, in the Swiss Alps or areas where you need you don't necessarily have the fuel capacity or basically any other ways to sustain it, like battery life. Blimps or drones have high endurance, so we focused a tremendous amount of efforts in two concepts. One is launching drones from this large blimp, and then working with other industry partners for urban air mobility when we don't need much speed.
Did that answer your question, Craig?
Yes, thanks.
Well, thank you. And if you don't mind sticking around, we'll do our last tour and then we'll have an opportunity to go back and get any questions that didn't get answered from any of the directors. The last tour is going to be the Atlas facility. We are here with the director, Waruna Senarvotne. I hope I pronounced that somewhat right. Welcome.
Thank you. Thank you. So my name is Varuna Sinaviratna. I'm the director of Atlas. I'm also the technical director of Composites Lab at NIAR. I've been working here for 20 plus years, primarily working on research programs from about 7 different federal agencies, including DOD, DHS, and whatnot. The Atlas is one of NIAR's new labs. We have about 100 staff already, plus the 200 from Composites Lab, which is the sister lab for Atlas. Primarily focusing on composite manufacturing. I know you're going to show you the video, but if I may, some of the advanced manufacturing equipment incorporated into Atlas. I hope you can see my screen. These are the same technologies Boeing manufacture aircraft. So these are industry scale equipment. We are focusing on basically creating the pipeline of future engineers who are industry ready. At the same time, working on research, we are working with industry on prototyping. For example, we have projects where some of the aircraft companies come to us. There are flying articles using the manufactured by hand, and they want to automate it. So, for example, you can see the equipment you see on the top there. That's one of the largest robot KUKA makes. You can see the precision of this equipment while making these large parts. So Atlas has a group broken down to 4 different groups. You can see the automated manufacturing, advanced computer-aided simulations like process modeling, the discrete damage modeling, high fidelity inspection, and structural testing. Just to show off a couple of our new toys, what you see here are the same technologies that Boeing and Airbus used to make aircraft. So the one on the left-hand side, that's the Electro-Impact company next to Boeing. What we are doing here is manufacturing a fuselage panel, a section of a fuselage panel. The equipment you see on the right-hand side, that is the equipment Airbus used for manufacturing their aircraft. Now, before we start manufacturing these, we have to go through a full manufacturing simulation. You can see the top right-hand video where we actually have to simulate the entire process. So the students that work at Atlas, when they go through 2 to 4 years of training, and when they graduate, they can be immediately integrated into the industry because these are the exact same software, hardware that industry is using. Another technology that we have incorporated into Atlas is the thermoplastic welding. When you look at aircraft composite parts, most of them have a lot of fasten holes joined using mechanical joints. But the problem with composite is when you poke a hole in a composite structure, you have a severe knockdown in your load carrying capability. So people go into a lot of bonded structures, but with the bonded structures, you had to worry about the surface preparation and things like that. So here, what we're doing is we are introducing thermoplastic welding technologies, go through simulations and basically building prototypes. So in the future, we can actually weld composites. So that's a very quick overview of kind of some of the technologies we have, but there are a whole bunch of other technologies. I don't want to take too much time to go through that.
Atlas Labs at Wichita State represent an investment in core technologies here in Wichita that focus right back around in manufacturing. Ever since the 1940s, Wichita became known as the air capital of the world, primarily based on all the advanced manufacturing technology we did, all the way back to the B-52. So if you look at what we're doing here today at NIAR with the Atlas Labs, Atlas is really focusing back on that core manufacturing technology that makes the air capital special.
At Atlas, we are using machine learning algorithms to detect anomalies in manufacturing environment and to increase the productivity through artificial intelligence algorithms so that overall productivity goes up and the manufacturing cost goes down. Atlas is essentially an extension to our industry's R&D labs. We are not just working with aerospace industry, we are also working with urban air mobility, even biomedical industry.
Atlas looks at all the advanced technologies and brings them into a focus where you look at quality, manufacturing rate, and cost, and wraps those all up into a manufacturing system that will propel us for the future. And from the university perspective, it puts us right back to our mission to be an economic driver for the community and also an applied learning model for the future workforce.
That was a great video.
Thank you.
Does anybody have any questions? This is a great opportunity. We have a lot of people from out at NIAR that typically we probably wouldn't get in all one room. So it sounds like they interact with each other. So they're here to answer any questions you may have.
I just wanted to say that this was great. We really appreciate it. It was a really great tour and you guys did a great job putting it together. Thank you.
Well, thank you.
It was very, very informative. Is there a way that somebody could send us some contact names, like an email out or something? That'd be very helpful.
I can do that. I can send the information to Stacy, who can get that all to you. I'll just send our briefing packet that includes contact information for all of our labs. And just wanted to let you all know, you saw 5 of our different centers or areas today. You did not see the entirety of all that is NIAR. We specialize in a lot of other areas that we didn't feature today because we don't have videos for those areas, but you can find more information on the entire breadth of what we do at niar.wichita.edu, and I'll send that in the packet as well. And just wanted to thank you all for being here as well. We haven't hosted an in-person event with 60 people in almost a year. So it's great to have you all here online, and hopefully at some point we can get you on campus in person soon.
Well, Tracy, thank you. That does bring up, I am going to do my best and continue to connect with you, and hopefully maybe later in the year, we'll have an opportunity to set up an in-person tour to at least one facility. So our members, obviously a lot of people are interested, and you guys do a lot of amazing things. So I want to thank you for being able to collaborate with us and get as many of your directors involved that you could. And it was very informative. So on behalf of WMA, I will come out. I told you I'll come out soon, and we'll present you with a plaque that we're going to provide for allowing us to have this tour. So
thank you. And there was a question in the chat about how you can keep up with what we're doing. We do have a newsletter that we send out that kind of gives you updates on things that are going on, workshops and trainings that are coming up, those kind of things. So I can get you all subscribed to that if you just send me an email and let me know. There's also a link on our website where you can sign up on our media page. But just reach out to me, I'll get you on there. We also have social media channels on Facebook, Twitter, and LinkedIn where we post new things that are happening.
perfect. Well, I think we'll wrap up. Everybody have a great rest of your week. And again, thank you all for attending, and we'll see you soon.